Welcome to Substrate Seminar, everyone. This is an exciting session. We have Massimo here presenting Subsquid. So Subsquid is an open, permissive, and decentralized indexing framework for Substrate and EVM. I'm going to quickly just do a few housekeeping items before we kick off. But I guess while we're here, Massimo, how are you doing?
I'm good. Thank you. Very excited to be here. Very excited to be a guest. And for what's about to come, we just spoke about New York, but I guess that's for later.
Yeah. So actually, that was one of my housekeeping items, sort of related. So you will see that in the poll, there's a poll section here that I put together to make this seminar more engaging, get you guys to participate more, and really I get it. I think that there's a lot of value in having people that are live today watching this use things like the ask a question box, but also for us to get an idea of who's in the audience. So one of the first polls I put was, are you participating in the North American Hackathon happening right now? So in case you didn't know, there is a worldwide hackathon that has kicked off. When, Massimo? It's kicked off from
30th of May or 31st, I think.
Right.
Yeah, it's been a couple of weeks.
So it's been a couple of weeks. So this hackathon is particularly exciting because for the first time, there are all of these great ecosystem projects building with Substrate, building in the Polkadot ecosystem, who have all sorts of really interesting bounties. And so for the first time, we have really great workshops by a lot of these ecosystem teams, like Massimo himself, who I believe did a presentation not so long ago. Is that correct?
Yes. As part of the hackathon, your colleague Sophie, hustled them, all of us, to present each and every one of the project a workshop. As mine was a sort of an introduction. Actually, I'm gonna do not a perfect replica, but most of the content of today is the same as the other one. I think that we have slightly different crowds, so it makes sense.
Yeah, absolutely. I think that on the seminar we have the opportunity to maybe be a bit more informal about asking questions more liberally and stuff like that. And also those of you who are interested to go even deeper on Subsquid, I'm sure you can go and find that video. Perhaps I can post it. So right now I can see that there's some of you who are already participating in this hackathon, some of you who don't plan on doing it this year, maybe next year, and some of you who are still thinking about it. So for those of you who are still thinking about it, make sure to follow that link. It's in the polls section of the Crowdcast. If you're watching this on YouTube, please head to the Crowdcast so you can see this and perhaps engage a little more in the seminar. So today we are talking about Subsquid. And for those of you who have already attended seminar, you will probably know by now that if you also wanted to propose some seminar, you would head over to this GitHub repository. And in this GitHub repository, you will find an issues section with some ongoing discussions about prospective seminars. So you could be one of two people. You could either be a team like what Massimo has done, where he proposed a seminar that he had in mind, which is the one happening today. And there's a review process whereby other people in the community can ask questions directly on this issue. And then that issue basically gets processed by me, and then we get to schedule it. And so just a really kind of great way to involve the community more in the Substrate seminars and whatnot. And so for today, you will be able to see the entire plan for our seminar. That way we also we provide you with links there that you can access directly. You don't need to be asking too many questions. You can do some reading before the seminar. That's the whole goal here. So all that being said, I think that's all of my items today. And Massimo, I'm going to let you share your screen and take it from there.
Awesome. Thank you.
So quick introduction. So Massimo is actually a developer advocate at Subsquid. And I think it's the first time that I have another officially just a developer advocate. A lot of developers are a lot of people that come on seminar. Yeah, they're kind of like a mix. They're usually like core engineers that do a little bit of developer advocacy. So yeah, it's actually great to have sort of another one of me.
Yeah, let me tell you, it's I think it's very hard to be a developer and do this sort of like outreach community stuff. I already like I have my hands full with this, and we're trying to like clone myself. So like a developer that tries to also do this is a lot of work.
Definitely.
I come from a developer background, but I'm really appreciate doing this sort of stuff. Unfortunately, you cannot do both.
Yeah, I feel you, and like at Parity, like a lot of our developers just don't have time to do this kind of stuff, and conversely, sometimes I miss doing a little bit of more developer-y
Yeah.
stuff, like working on some workshops and stuff. But it's definitely a full-time job.
Yeah, the secret I think is really trying to find the balance. We were discussing a week ago, 2 weeks ago with Dimitri, our CEO, how I can sort of try and be closer to the core development. I think we both thought that it would just be more beneficial, even more, because you get the information firsthand. You don't have to sort of scour the Slack chats and whatnot to find the newest things. But
Definitely.
Getting started with the presentation, the goal of the workshop that I have prepared for today is building a unified API for indexing both EVM and Substrate data with Subsquid. This is to sort of showcase the duality and the versatility as well of the Subsquid SDK. You can see here the Moon River logo. It's going to be more evident when we get to the practical bit. Why? But like spoiler alert, we're going to build the index data on the Moon River chain, and that's because it is an EVM compatible blockchain. Well, it has already been said. Who am I? A developer advocate at Subsquid. You can find my social links in here. And I think same as the aforementioned probably more straightforward version of this workshop that I've done for the Polkadot Hackathon North America. I'll put links in the description or in the chat of this deck of slides, so you can probably do it, follow it on your own pace. So what is Subsquid? We call ourselves, we try to be or become the best data backend framework for Web3. We have developed and are developing, we keep improving. We're going to see it at the end. There's a new release coming up we aim for Polkadot Decoded, so next week. So we're a framework for robust and natively multi-chain APIs. And the reason, one of the main goals, one of the main usages of these APIs are analytics or dashboards, stuff that basically shows the value hidden in on-chain data. We also offer a hosted service, and we are available on 33 networks and counting. The reason why we say we're available is going to be more clear in the next couple of slides, but we are technically by default available for any Substrate network. The only difference is we have to deploy what we call a Subsquid archive to be fully legitimately available. The main goals we set to when we started building Subsquid was to build to scale, to be fast, to allow for fast synchronization, and to be able to handle large amounts of data, huge amount of data, because we bet on the success of Polkadot. That's the idea. We're heavily focused on customization. The wink there, with a few exceptions, that we try also to cater to people that need more cookie cutter solutions. So we have sort of this dichotomy of heavy customization for those who want it and need it. And we also came up with a solution for those that have very common, very basic needs. Like I said, we aim for fast development times and fast sync times. But taking a step back, why a data solution? Why an indexing middleware is needed? The reason for the existence of these solutions is that blockchain is made for writing data, a lot of it, and in a very secure way. It's made to, the technology is great for validating data, but it's not designed in principle to extract it. To extract it is quite a pain in the butt, if you excuse me the French term, because it's written in a linear form. It's like writing a book. This is sort of like a very common example. It's like writing a book where if you have to find the exact word at page 177, you have to scour the entire blockchain to find it. Whereas with an indexing solution, kind of like an index in a book or in a PDF, you will find the exact word that you are searching for. And also, the demand for blockchain data is only increasing. Like, the more we write data to the blockchain, the more we want to read it and want to like exploit all of that. One of the cookie cutter solutions, I'm going to show it at the end of the video of the workshop, is something to explore the usage of chains and parachains, which is very important also for Parity themselves. If you want to, if they want to sort of monitor the success of the various projects in the ecosystem. So, for example, you want to see when people contribute to a crowd loan. You can see the behaviors of people. Maybe it's because they interact a lot in the project. They have a lot of transactions. And so the way to do it, obviously, is the only, I would say, way to extract this data is through a middleware. The way we Subsquid are different, or we think we're different, and in a way better because we design it this way, from other similar solution, is because of the approach to the architecture. Typical indexing solution try to do everything in one place. They're what we call monolith. So the indexing and the processing is done by the same entity. It's your application. The indexing maybe is not custom. It's done always in the same way, but you add your processing on top of it. But the problem is this monolith has to do a lot of RPC calls to the blockchain, and that is by definition very slow because the blockchain represents a bottleneck in performance. The RPC calls are not done, once again, specifically for this. And if every API, every person in the ecosystem, every dApp wants to do this, well, the blockchains are going to be flooded by RPC requests to read data from it. It's also not very resilient to runtime upgrades, which are awesome, but they present a challenge because when the data written in the blockchain changes of structure, the indexing solution that extract this data has to be aware of the change. And we designed something to handle this. I'm going to talk about it once again later in the slides. So to counter this, our proposal was to split this into two layers. We have what we call archives, Squid archives, which pre-index the data, the on-chain data, and they keep it in a raw format. But it's this is very easy to exploit data. It's very easy to query, especially like it says here in batches. So this back and forth operation is much faster than this, because also this is done only once per archive. Once the archive has finished indexing the data of the blockchain, it just keeps in sync, and it's available and it's shared by multiple processors. So when you have to build your API to leverage on-chain data, you just have to connect to an archive and develop your own business logic. You don't have to care about the indexing. And also this saves a lot of storage because the data is not duplicated. It saves a lot of bandwidth because you only care about the data you care about. You don't have to index the entire blockchain. We have done it for you. And basically, in a nutshell, the archives take care of the heavy lifting. They do the groundwork. They do the heavy work for you. And it's winning because what I just said, it does the heavy lifting. Pre-indexed data is queryable, and it has the entire historical data. they are by definition faster than RPC calls, because those archives expose APIs that are designed to be very I/O intense. The other winning point, we think, is that an indexing solution has to be flexible to allow heavy customization. We know that most of the needs are very similar when it comes to dApps and frontend, but some of them can be very, very peculiar, very even weird if you want to. And so you want an SDK that allows you to be as flexible as you can. We allow, for example, to index not just Substrate and EVM, but do it in the same project, like we're going to show in this presentation. You have also full control of the database. You can decide any entities and the shape of them that you want to. You just have to develop what we call handlers or mapping functions that take on-chain data and put it in the right database entities that you defined. And it's as flexible as we said it is, because it allows you to do pretty much anything you want to. You can even bring in external libraries and call external APIs to augment your data with external data. We have an example, our friends at Talisman, who use Subsquid for their expanded view of the wallet. They use this to not just call CoinGecko, but they also fetch assets such as the images of the logos of the crypto projects, and they even do this. They even do basically have some sort of cache layer where they know the amount of decimals, because when you fetch a price from the blockchain, it has it's an integer. You don't know where the dot is going to be, if it's like 10 digits or 12. So they store this in a separate API, and they use Subsquid to do one call, which reduces the network load. And so the result is a very snappy front end, which just does one query, and it has all the data that it needs. Yeah, there's also like heavy, when it comes to heavy customization, there's stuff that goes very deep in the customization, which is custom resolvers. You can add custom SQL queries that are going to be basically, they're going to be defining, you can define a query, a GraphQL query, via a custom SQL query, which allows you to be very flexible. And once again, I'm repeating a lot of these terms, but this essentially is the key for us. One other very useful thing that I found myself, and that we have been told by users, is that because it's a very simple project, in the end, it's a node project with Subsquid libraries. You can do local development, you can test it, you can break things, you can do like find bugs very early, and then if you want to, you can use our cloud solution to host your project. Vice versa, other similar projects sort of force you into a black box sandbox environment where you just define your code, push it, and that's when you find issues, which is obviously inconvenient. I already mentioned fast sync times and the reason why, and the serverless deployment is the hosted solution that we provide. The last thing I'm going to talk about in terms of feature is the automation. We know for certain, every developer knows this, that manual labor is error prone. So the more you can automate, the better. It reduces bugs, and it reduces also inconveniences, and it takes away the boring stuff essentially. We have a coding, a code solution, a command line solution to generate code from schema. Basically, you define your entity in a GraphQL dialect, and thanks to a command line tool utility, you have a TypeScript model as a result. And another useful thing that we have is what we call TypeGen. We generate type-safe wrappers for Substrate entities such as events and extrinsics. And with this is the usefulness or the issue that I was referring to earlier. When there's runtime upgrades, this is v0 of the transfer balances.transfer event, the transfer event in the balances palette. And it used to have 3 fields. Then a fourth one got introduced, which was the fees. And then later on, it got taken away again. And especially starting from a certain metadata version of the blockchain, the underlying structure is also different. They are decoded slightly different. So what we do to save troubles to the developer, we essentially generate we explore the blockchain. We look at how many times and when and how a certain event you might be interested in has changed throughout the history of the blockchain, starting from the genesis until the head block. And we create the type safe wrappers that I was mentioning. These are classes, once again, in TypeScript that are, I refer them as self-aware. So they know the hash of the block that has introduced a change. And when you explore the blockchain, they refer to this and they say, oh, I'm still at the correct version. So I'm at the runtime version 49. And so I can decode the information contained in the event this way. So it has the 3 fields that I mentioned, the to, from, and the amount. And later on, like I said, this is, by the way, different. You can see different runtime version, because I think that this is Kusama, I think, which has 9,130 version of the runtime, whereas this one is the blockchain that we are going to take a look. I'm pretty sure, which is Moonriver.
So, Massimo, do you mind if I interrupt
Absolutely.
you just to ask questions, hopefully to clarify some points here and whatnot? So I really liked how you basically started by saying, like, a monolith versus modular. And my understanding is that the architecture of this really makes it such that you can really kind of like basically adapt the needs of whatever project.
Yeah.
Thanks to this architecture. Otherwise, in a very monolithic architecture, you would really need to sort of re-implement certain things and stuff like this. Here, it's very modular.
There's duplication, essentially.
Then you mentioned that,
sorry if I reiterate, but there's duplication, right? Yeah.
Less duplication, right? Right. Yeah, like less code duplication. And then, so one thing you mentioned is the challenges, and the challenges being when you make a runtime upgrade, well, there's a lot of things will break actually if you're trying to query something that is from a previous version. And so I think there's a fair amount of people in the audience right now today that are watching who are more like runtime developers. So they're probably very familiar with this. So just for those who maybe aren't, essentially the version of the runtime is always sort of can you talk about how would something like this architecture detect a change? And when to know when to upgrade, and then when to make the delineation between 2 versions.
I sort of like take this stuff for granted, but you are absolutely right. I think it's better if we go into slightly more detail because luckily we have time. But essentially, let's imagine that at block number 1000, right, there's been a change from V49 to V1201, and this has introduced. Actually, let's go back one step, because this one it provides a better example. So V0 is the starting version, right, from Genesis block. At block 1000, right, we have introduced version 1020 of the runtime. The block number and the version number are 2 different things. First of all, it's important to understand. And this has introduced the fees. So what happens is, if I try to decode the transfer event information on block 1000 where a change has happened, and I'm going to try to decode it this way, I'm going to be in a pickle, because I'm going to try. It's a matter of, every developer knows the signature of methods. It's like I am running on old compiled code where the new method has a different signature. So the two things basically are not going to match. They're going to clash. I think it's the opposite might be even worse, because when we pass from this version to this version in, say, block number 10,000, right? It's going to be even worse, because I'm going to try and extract 4 fields out of some binary information that only contains 3. And so I'm just going to have an error. This is where bugs happen, essentially. And what we do to counter this, to answer your question, we have the Typegen tooling, which we're going to execute in a minute. So it's going to be more visible in a second. But we are exploring the blockchain first. We look at the number of what we call spec changes, which are the runtime changes.
In the runtime, yeah. So the spec number is indicative of, hey, there's been an upgrade. So these types that are really defined inside the runtime. So it could be a function, but it could also be some sort of custom type. And oftentimes, like runtime developers will make their own custom types. So anyways, it's an indication that there could have been a change. So then you need to adapt to that.
Exactly. The command line tool is basically extracting all of these spec changes and the metadata tied to it. The metadata has a description of what functions and types are described in the runtime. And what the Typegen does, which they work hand in hand, because the Typegen looks at the metadata and says, oh, you're interested in, I have to specify it, right? I have to, as a developer, I have to configure the Typegen and say, I want to extract, I want to create wrappers for the transfer event in this case. So it's going to look at the metadata file and say the runtime the runtime has modified the transfer event 3 or 4 times, or 2 in the case that we have in here. It has changed twice, and so it generates a class for the transfer event that reflect these changes. Essentially, it's just reading the metadata and creating automatically some code that is aware of these changes. I say aware because I think it's the best definition, right? It knows that
because
the
ultimately
event has changed.
We're talking about building like applications that need to have this awareness, because otherwise they're going to try to read something from, block before whatever 1000. Let's say that was when there was a change in metadata or types, and they'll just be lost.
Yeah, exactly.
That's a great way to put it, for sure.
Yeah. Like I said, we're going to see the practical application of this in a few slides when we start to when I stop talking and start coding, actually. But I wanted to touch on the EVM side of these things, because we're not letting EVM people alone. We do the same thing for ABI. Essentially, when you want to index, say, once again, the transfer method, the transfer topic of a contract, first of all, you need the contract. So you need the ABI, the interface for the ABI stands for application, right? Application binary interface, I think. So you need it, and that is the equivalent of the metadata that I was talking about. It has the signature of every topic, every method, essentially, that can be applied to that contract. So what we do, we read it as an input, and we, as an output, create TypeScript decoding function. This is the input, right? I was talking about, let's say, I think this is the approval topic. I like to call it a method, because in the end, it's the approval action, let's just say, and it has these inputs. So in my view, it kind of reads like a method. It might be like, it's a terminology thing. I like to think about it in my head that way. But as an output, this is what we do. We create, first of all, interfaces, right, for the various topics that we're interested in. In the case of today's project, it's once again the transfer. And this is why I like to say that they're methods, because the full description of the topic kind of reads like a method. I'm transferring this amount from this address to this address, right? And I have a handy decode method to decode the information contained in the event log.
Cool.
Yeah. I think that the boring description part is over. We have these links in the in GitHub for this seminar, but I want to reiterate that we have documentation. We also have documentation on Moonbeam site, and for those developing or interested in the Astar ecosystem, our EVM solution works for both. And the template projects is where we're going to start in a second. And the aquarium is the name of the hosted service. Well, if you think about it, your APIs that you're going to develop, we call them squids because we're Subsquid. And so where do squids go if not in the ocean? They stay in the aquarium.
Love it. Love it.
Silly pun, but we like to be that
So
way.
actually, one random question on the top of my head right now is: so why Subsquid? Is there within your organization? Do you talk about the squid symbolizing something in particular, or I don't know?
I think like this has to be with this traces back to Dimitri, our founder. He generally liked the word squid. The typography of the Q letter, like he said it in a couple of AMAs. I did not even know. I didn't question when I got into the company. But like it's pretty much just for the lols, no particular reasons. And he likes this like squid as a dish. So
I agree, and I like it as
Yeah.
a creature too.
Yeah. Oh, yeah. Like they're funny with the tentacles, etc. Like we're trying to find some clever illustration that basically uses the tentacles to sort of portray the image of we reach our data middleware reaches every corner. I think we can go ahead and start coding. Like I mentioned in the beginning, we're going to build a tracker for ERC721 tokens and mix it in with substrate transfer to showcase the ability to index both EVM and substrate data. We're going to start with a setup by cloning the template. We don't have a command line init tooling yet. We're evolving very fast, and we didn't want to invest in something like that when a template just does the job, essentially, because the template is a self-contained mini project, and it even serves as a showcase of what a mini project looks like. We're going to review the schema to make the necessary changes. This is usually where everyone developing with Subsquid should start. You have to have, first of all, a clear idea of where you want to go, what your API should look like in the end. And then generate models, generate the interfaces. This is where we're going to take a look at the practical application of what I just discussed. Finally, implement the logic, launch the database, and apply migration because, well, we let you do anything you want to with the database, but we also supply with the tooling to not having to deal with the minutiae. And finally, launch the processor, start processing data, and serve your API with the GraphQL server. So the only requisites for, well, today's workshop, but any Squid project is Node.js and Docker. We're going to start with the template in here. It's in our GitHub account, Subsquid, and you can find Squid template. If you have any questions, anything, I'm just going to go cut me off whenever you want to. We can say Substrate Seminar.
Cool. Yeah, I suggest that people who are down, they should just follow along. I'm gonna try to follow along myself, and also feel free to use the question box to ask your questions because that's also why we're here.
Yeah.
Cool.
Oh yeah. I see the people linking in the documentation. That's awesome. Thank you. There it is. So I'm just gonna copy the link to clone it and clone it in my local machine. There it is. Just open it up. So when we cloned the template, when it loads, this is how it looks. We have a couple of sort of auxiliary folders like archive and scripts. Archive is in case you want to launch your own local archive. Let's say you run a devnet, not even a testnet, something that is not publicly available. We provide you with a Docker Compose file to launch it, and you can do even local development of your future APIs without even being live. Then we have a couple of auxiliary scripts. The Docker run, I'm mentioning this one specifically because it's useful to test locally if the deployment on our hosted service is going to fail. Because maybe it runs locally, but you have not realized that, I don't know, your GitHub repository is not up to date, or the Docker file Docker build actually fails. So it basically anticipates the issue and you can fix it. Then another thing worth noticing, I think, we have a Docker Compose here, which only has a service, which is the database. Of course, we take data out of the blockchain into the archives, which is completely transparent. Then the API we're developing today is connecting to an archive, and well, it's processing stuff. Where does it put it? In a database, of course. So this is it. This is the Docker file to pack everything up that I just mentioned. And like I mentioned, this is a Node.js project in the end. So we have package and package.json, .log, sorry, and the schema. This is where we start right now. But first of all, I always forget. We have to obviously install dependencies.
Cool. Yeah, I pasted a link also for those who wanted to follow in the chat. All of this stuff is nicely laid out there.
Yeah, while we do that, I think we have to install the dependencies, but we also have to install further dependencies specifically for today's project, and I'm gonna explain why later on. So these are all Subsquid libraries that allow, and well, there's also Ether project libraries, but they're usually included in EVM specific projects. But basically, they allow to introduce EVM compatibility to the baseline project. The base template is sort of like quote unquote substrate only. We're gonna add the EVM compatibility to it on the go, even though we're gonna see it later. We have an EVM template that does it for us. But I think it's nice to see the whole process. So we're gonna copy paste the further dependencies and install them.
So actually, Massimo, at a high level, like, what blockchain are we connecting to? Are we just gonna run some instance locally, or are we gonna connect?
Yeah, good question. We're gonna see it in a second, but let's jump ahead to it. I'm gonna jump ahead to the question and to answer your question, and then we're gonna flip back. We're going to connect to Moonriver.
Awesome.
Like I mentioned, the logo at the beginning of the presentation was because that's the blockchain we're going to use today as a reference. Let's go back real quick. Cool. There it is. Okay, we're going to change the schema. Like I said, this is where we start. The base schema for the template only takes a look at the account and historical balances of those accounts. Basically, it's a transfer. Actually, let's take a look at the processor. I think it makes sense to see the logic before we touch it. Once again, this is the template, and like I mentioned, this is a fully functional small sample project. Of course, it imports the necessary libraries and whatnot. But the core of the logic is here. We instantiate a processor class, aptly named, because that's what it does. It processes data. After a little bit of setup, in this case, we set the data source. And as you can see, it's done to, it was built to process the Kusama network. And this is where the magic happens. The way the processor works, it's almost like a publish subscribe, I keep saying, because we specify, we sort of subscribe to the balances.transfer event, or we tell the processor that that's what we're interested in. And we also specify the function that should be handling those events. What the processor will do is every time this event is encountered, it's going to trigger this function. In this case, it's an arrow function, and the only requirement is that it has to be asynchronous, and that it has to accept, like you see here in the tooltip, it has to accept an event handler context. This is where we will find useful interfaces, such as the store interface that is used to save our entities on the database, for example. But it also contains things like extrinsics linked to the event. For example, in this case, we extract the tip, and like we can take a look at it real quick. I think. Let's see. There it is. So the event handler context that is passed to our function contains the store. Like I mentioned, it's the responsible for the communication to and from the database. The block that we are observing at the moment when the function has been triggered. Let's say the processor starts from Genesis block, asks the archive, can you give me all of the blocks that contain this event? The archive responds with a batch. That's why we have this setting, a batch size, because we process stuff in batches, right? And then the processor goes on to, ingest them one by one, block by block. And if while processing a block, it encounters the event, or rather when, not if, it's guaranteed because it has asked for those blocks, it triggers the function. And when it triggers it, it passes this context. So we have the block that triggered the event, that where the event has occurred, the event itself, and the extrinsic that has likely triggered the event itself. This is pretty much all I can think about, all I can say right now without getting to the boring details. But essentially, this is all of the information that we have to accomplish what we came here to do. We can encode the transfer, the addresses with the right codec, and we save them into the account entity defined by our schema, right? We set the correct field. For example, we want to calculate the balance, and we want to subtract the amount minus the tip in the case of the from account. And then we save two sort of snapshots of historical balance. I think that the logic here is not very interesting. It can be as arbitrary as we want to. It's just an example. And matter of fact, we're gonna do something quite different today. Like I said, we're going to define different entities for today's project. We're gonna keep track of token transfers. We're gonna keep track of the ownership. Our account entity, we're gonna rename it to owner and add some other information, and then we're going to maintain track or keep track of the contract itself, because it will have information about the name, symbol, total supply, and minted tokens as well. And finally, we keep the transfer entity. Oh, and actually, this is the one we add. Sorry, I'm getting confused. We also adding a transfer entity. So that means that every time we record a transfer of the ERC721 token, we are going to save that information and we can use it. For example, we want to create an NFT dashboard. We can keep track of every time our NFT has exchanged hands. I think this is a very common use case. Actually, I'm basically describing what projects like Codegen and others are doing.
Right. Yeah, but going back to why we're doing this is always it's helpful to understand like how we can use it. And yeah, basically that's what we're trying to accomplish. Create more user-friendly applications, create more user-friendly tools for developers to create these applications, right?
Yeah. Like good point. Like if we imagine doing this without a middleware solution, you would have to sort of like scour the blockchain history yourself. The reason actually why Subsquid was born is that at the time Dimitri was working for Joystream. It's a video streaming project on Polkadot, and they wanted to do some data collection, and they had to build. There was no solution, so they had to build it in house, and Dima quickly realized that this was probably something that other projects would be interested in. So he branched off and became its own project, Subsquid.
Super cool. Massimo, there's actually a question.
Forward a little bit.
Just a quick question before you move forward from Rutger. And so Rutger is also, he made a comment in the chat saying that he loves boring details. So don't hesitate from going to some boring details. You can feel free to do so. His question is, so writing the GraphQL schema is like writing a REST API interface, basically?
Yes. So we're going to see it in at the end, but at the end of we're going to see the end result. But at the end of the day, the schema, it's going to be how your API will look. This is sort of like the hidden power of GraphQL. It's a very declarative way of defining your API. Essentially, your schema also becomes it's used for everything. It's your database schema and it's your API schema, right? With one, you basically hit two birds with one stone, essentially.
Cool.
Once we have defined the schema right here, as we said, we're gonna use the command line tool that I mentioned earlier, which is as a shortcut we have SQD. SQD is basically once we have the library called, let me just put it up, Subsquid CLI. This has allows you to access to all of the command line tools that our library provides, and one of them, they are all under the SQD namespace, and one of them is called Codegen, and it's the one that we're gonna take a look at right now. It's basically going to read the schema.graphql file, and it's going to make changes to this folder, models.source models generated. And the changes that it's going to make is it has right now generated as many files as the number of entities that we have defined. And if we take, for example, the owner one, we can take a look at it real quick. It looks exactly like the schema we have defined. It has translated GraphQL into TypeScript, essentially. So we look at the owner. It has an ID field, owner tokens, balance, and historical balances. And as you can see here, ID, own tokens, balance, historical balances. A quick note about these two fields, own tokens and historical balances. You can see here that it has a decorator saying one too many. That is because this is what it is. It's a relationship. It's a relationship between the owner entity or model with the historical balance and the token models. And it's the cardinality is one owner can have multiple tokens, can have multiple historical balances. Because, well, if you think about it logically, Historical balances are snapshots of the balance of this owner throughout time, essentially. So that's why you have multiple of them. There it is. Moving on. Oh, well, I've done the same thing in the presentation. Now here comes the juicy part. This is where we had a little bit of discussion earlier. I think that doing the practical part would make a lot of sense. We have this command, and I'm going to first of all copy it and then explain it. What this does is it's another command line tool. For some reason, don't ask me why. It's not under the SQD namespace. It's its own command. I think the project is going very fast, and so like some of this stuff is not fully standardized. I think in the future you're gonna see in the coming months we want to make all of this more streamlined and standardized, so that you can say npx SQD metadata explorer, so you don't have to remember a very complex name like this one. But what it does, it does what it says, what the name says. It's a metadata explorer of the Substrate runtime, and you have to provide a couple of arguments to it. The chain, which is the URL, the endpoint of an RPC node. It has to be a full archival node, because it has to contain the entire history of the blockchain. You can provide, this is optional, but it allows you to go way faster. The archive, this is the Subsquid archive of the network. And the last parameter is the output. This is where we're going to store the sort of like the spec versioning that metadata explorer will find.
So
let's
in
launch
connection,
it and see what it
in connection
does.
to what we went over earlier, Massimo, that this version JSON that's going to be created is going to help determine sort of when to change the expectations of the shape of the schema ultimately that comes from runtime upgrades, types that are different perhaps on block N and block N plus 1, right? And as well as metadata versions,
yes,
right?
That
so
is
right now
exactly
version 14 is the current metadata used. However, last year, for example, it was version 10 or something. And okay, that's really cool.
Yeah, by the way, version 14 has simplified a lot of things. Before, we also had to deal with the types bundle. Like you said, runtime devs could specify custom types, and it was a little bit harder to deal with them prior to metadata 14. That is that much I know from experience with our own tooling, at least.
Yeah, I know from the Parity side.
Like you said.
I'm sorry to interrupt you again. I was just kind of adding a comment
to your
it's
last
absolutely
thing, fine.
And I wanted to segue into one question that just popped up from Hissam. So Hissam is asking, if you have block under version 10 and you have latest version 15, there's 5 versions difference between 10 and 15. And there's going to be many different upgrades. How do you deal with the fact that there's all these upgrades between these different versions? And I think really what he's wondering, it sounds like he's actually really curious to be building with Subsquid, is what's the performance burden and delay?
So I'm trying to understand both actually. The first one is about the gap in between the two versions that were found, for example.
I think he's saying how do you deal with constantly needing to update the schema when versions change? And then the second part is really asking, what is the burden here? Is there a performance cost?
Not necessarily. The performance cost is just having to be more verbose with the at the end of the day, when you have to decode an event, you have to sort of have either an if else chain or a switch case that compares the the event version and extract it with the right sort of like decoding function, right? That is the there's no really not really a performance burden to it, because it's just an easy a quick check, right? It's almost like the complexity is all one, I think, it's just like a quick comparison. But the first question is, if every time there's an upgrade, I need to redo this process and change the schema. The schema shouldn't change. What changes is that you have to regenerate the type-safe, the type-safe interface, the type-safe wrapper around the event, and you have to update your decoding function. Let's just take a look at it practical, and then I'm going to point to exactly what I just mentioned. This is the content of the typegen JSON file. This is the configuration file for the command that we're going to run afterwards. It's to avoid having too many arguments, essentially. But I wanted to, since this is done, I wanted to show the result of this metadata process. So this is a huge file, as you can see, right? And what it has, let me pick it up if I am good enough with my mouse. Yeah, there it is. It has multiple objects, right? That have various fields. They have the spec version, the block number, the block hash, when where the change of the version happened, and the metadata. It's a series of this many blocks, essentially. And it's, like I said, it's the result of the exploration. Looking at how many times the version has changed, and keeping store of these three essential pieces of information. The block hash is used for the comparison, and the metadata is what contains the actual information about the runtime. It's the one that is being used to generate the footprint of the event, essentially, which we're going to do in a second. I'm going to close this down, open the typegen. Like I said, this is the configuration. It's how we want our command line tool to generate the type safe wrappers for us. So what we are telling it to do is that the output should be this folder, that we want it to take a look at this JSON file, the one I just opened up, that the types bundle, what I just mentioned, that for chains that have history prior to metadata 14, we also have to care about the bundle of types, because sometimes they contain custom types. And finally, this is purely this is the pure configuration aspect of it. We want in this project, we are interested in the balances.transfer event. We are not interested in any calls nor any storage types. So it's going to take all of this information, and when we execute it with this command right here, I'm going to take a look at this folder. You can see it live, that it's going to make the necessary changes. As you can see, he has regenerated the folder, and it has new content in it. Because we told it to keep track of the changes that have an impact on this event, and we told it that we're interested in this event particularly, it has created this class for us that has, like I said, in the slides, we have the actual Moon River history of this event. So we have two changes in the history of this event. This is V49, I think is the base runtime of when the chain Moon River got created, is how the balances.transfer event was born, having these three fields, from, to, and value. And they are reported as an array. they're decoded this way. Starting from version number 1201, this is where metadata 14 started, I think, because I noticed that when I do this across various blockchains, at some point they all become objects that have sort of like self-documenting field names, which is actually kind of nice. And yeah, it changed from essentially, it didn't change the content of it because we still have 3 fields, right? But it became an object that have self-documenting fields. So it makes life even easier for us. And we're going to see how we use this in a second when we skip ahead to the processor logic. But first, because this is part Substrate and part EVM, we're going to have to take a look at the ERC721 ABI. We have the JSON for the ABI somewhere. It's easily sourceable. I mean, it's a standard, so no big deal there. And we imported in our project and launched this time it's called the EVM typegen. Slightly different syntax, but the result is going to be similar somewhat. So we create a folder named ABI and the file named ERC721 JSON. There it is. Like I mentioned, the ABI is the interface defining the binary interface defining the topics, or like I like to call them, the methods that are available for a given contract.
Yeah, it's really equivalent to the metadata generated by a Substrate chain, right? ABI analogous. Yeah. I
have an extensive experience in development, but I'm pretty noob when it comes to crypto. I only actually started looking into development starting from January, but that's how I think of it. Right? It's pretty much the equivalent in 2 different spaces. Launching the command, it's going to generate, because we told it so, a file named ERC721TS. And this is how it looks. It has generated interfaces for all of the topics contained in the ABI, and it has generated. Well, this is annoying. It's it's ESLint just bugging me a little bit. We're going to do this real quick because I don't want to be bothered with fixing all of the linting issues. You shouldn't be doing this, but for the purpose of today's workshop, let's do this. Looks better. So we have, and let's do the prettified. Okay. It has looked at the entirety of the ABI of the interface, and it has generated all of these mappings from the topic name to the topic actual sort of definition, and it provides us with decoding function for all of them. The one we are actually interested in today's project is this one, transfer. Once again, we are going to keep track of all of the transfers that happen on a specific ERC721 token, a specific contract. So there it is. We can move forward, I think, to this is where we're starting with the actual logic. We're going to create a file named contract.ts that, like the name says, is going to handle the contract. We are instantiating using the ethers library that we installed earlier. Instantiate a new contract, and we are also going to create a new contract model. Like this have the same name but different namespace, because this is the ethers contract entity sort of, and this is the contract model that we have defined. It's the one generated from our schema. I could have called this one, my own contract or like, foo bar contract. They're two different things. And the last thing that we have here, it's sort of like a utility function that we have that fetches the contract entity, so this guy right here, from the store, from the database. It's basically a check. Do I already have a contract on the database? Yes, then I don't have to create. It's sort of like a get or create one, if you will. Let's copy the code, and I think it's going to be easier to look at in VS Code. Let's close this down, It's actually very weird to code in such a condensed UI, but I'm not used to it. There it is, and let's save it as contract.ts.
Squid tracks. Yeah, I'm following, by the way. I hope other people are following too. It's fun. So in the return contract object, you've got like a symbol msama. Is that arbitrary, or will it bug out if it?
Yeah. This is arbitrary. Good question. Sorry, I didn't mean to cut you off, but you touched on a very, very good point. I think it's worth visiting. Let me. I think Moonscan is a great tool for this. Yeah, there it is. So, for those who don't know, apart from Subscan and whatnot, there's also another tool specifically for Moonriver called Moonscan, and it's mostly for the EVM part. As you know, like Subscan looks at the substrate part of it, but when it comes to contracts, it's a bit lackluster. And whereas this one has specific, ERC 20, ERC 721, etc. So what I did, I was interested in the Moonsama NFTs, right? So what I did is I just Moonsama. Oh, don't know. I don't remember. Maybe I'm using the tool wrong. But what's interesting for us is the contract. It doesn't matter. I'm not interested necessarily in the token. I'm interested in the contract. I landed on the wrong thing. I don't know. Anyways, this is the actual token I'm interested in. I think I found a clone of Moonsama earlier with the research. And you can see all of the information that we are using in the in the project today. So this is the token name, the total supply, the symbol, right, msama, and the actual contract address. And you can find them here: name, symbol, total supply, and this is the address. B6546, B6546. Yes.
So yeah, we need to make sure that those are consistent with
this. Is exactly this is like prior information you need to have, of course. Like if you want to find, let's say we want to do something completely different. Cannot remember block scout. Yes, there it is. If you want to, for example, do something completely different and monitor Aster EVM contracts, they don't have an equivalent, but the block scout is a good tool, and we can look at the Aster subsection here. I can find any arbitrary contract in here and do the same thing. We can find, the right address, the right ticker, and supply etc. information. Obviously, I need to do redo the chain exploration and type gen because it's a different chain, but I can do it.
That makes perfect sense. Cool. Thanks for clarifying that. It just shows how modular really this is.
Yeah, exactly. Obviously, this is information that you should be having when you set to developing something. If you are interested in a different contract, it's only important that you have the contract address and all of this information.
Rutger here in the audience made a good point. Maybe you got confused because you were looking at Moonbase versus Moonbeam versus Moonriver
It could very well be.
contract.
It could very well be. But let's actually Moonsama. I think, yeah. Oh, there it is. That's why. You see, I was looking at the ERC20 token, whereas what I'm interested in is the ERC721. That's where we find exactly this one. So I click on the wrong wrong type of token. Okay. So going back to the presentation, we have dealt with the contract itself. This is just auxiliary stuff that I chose to have in a different file just because it was handy. There's no need to do, like, you can structure the project however you want to, especially if it gets complex. It's useful to have, some sort of like modularization where you have helpers folder with multiple functions, etc. For example, the fact that I chose to have the contracts in the ABI subfolder is completely arbitrary. There's no necessity for actually doing so. And we move on to the processor logic. This is where like I said earlier, the magic happens. We're gonna, I think, copy it first and talk about it then afterwards. Like, obviously here we still have the old logic, and as you can see, it's very mad because we changed everything. So it's trying to, look at the account model, which is no longer there. So we're gonna remove it and paste the new. What did I do? Okay, it's just, yeah. Okie doke. There it is. Yes. So skipping the imports because, well, they are a necessity. There's nothing very interesting apart from maybe the fact that we import the Substrate EVM processor and not the Substrate processor. We import the get address from the Ethos project library that we installed at the beginning. And of course, we want the mapper from the other file, from the contract. No, sorry, from the ERC. So we want 721TS. We're importing this bad boy right here, and all of the models, because of course we are. Like I mentioned in the beginning of the presentation, the processor is the mapping where we translate on-chain data to the final API schema that we want. So it's only natural that we save the information into the models that are derived from the schema and the types event from before. So we instantiate the processor. Set the data source. In this case, I chose to have the chain node into a constant that was defined in this file right here. It's the Moonriver network, once again. I chose to have it as a constant because I also have to instantiate a WebSocket provider. So once I use it twice, might as well turn it into a constant. We have two things right here happening. Oh, three things, actually. The first one is the processor has that, how do I say it? Like that publish subscribe mechanism. And it works for multiple things. It works in this case for every time we encounter the pre-hook is every time we encounter a new block. Before executing anything else, we tell the processor, please trigger this function. Right. This is what a pre-hook does. It tells the processor, as you ingest new blocks, before doing anything else, run this function. Then you can move on to executing all of the event handler, all of the EVM log handlers, all of the extrinsic handlers. And finally, we also have a post hook, which is a hook that happens after everything else. But in this case, we leverage a very peculiar, well, not peculiar, but a functionality of the hook. We specify a range. We essentially tell it to run only from block 0 to block 0. So only at origin. We only need to run this function once. And the reason why is because we use it to instantiate the contract entity. So we basically do a little bit of tidying up in the house. We just say, before doing anything else, create the contract entity, and then we're good to go. This function will be ignored going like for the rest of the history of the blockchain exploration. The second thing that happens is the EVM log handler. We are defining a function that will have the task of process all of the ERC 721 transfers. We specify the address that we wish to subscribe, and we can further filter it down by saying we're only interested in the times where this topic of this contract is getting executed. So if, for example, another topic of the same contract address is getting executed, it's going to be ignored. We're essentially filtering down to save time on execution. This is something like a little bit of, I don't know, tooltips, or tooltips, some tips to improve the performance of your Squid API that you can apply. And then the last thing is we subscribe to the good old balances.transfer substrate event, and we have another function dedicated to processing that. Finally, we start the processor, and then it's going to basically be living in an endless loop, because even when it gets to the head of the blockchain, it's going to keep sort of ingesting new blocks as they are being created, as they are being minted. But looking at the logic of the process transfer, it's not that different from the previous one. The only difference is that we use the 2hex function because Moonriver addresses are not SS58 encoded. They're hexadecimal. They are in the format of Ethereum addresses. It's a particular thing on the Moonriver network, but I thought it was worth noticing. The next thing is just like before, we instantiate the owner models. We save the right information to each and every one of those. We take snapshots of the balance, and that's pretty much it. This is the new stuff. This is what we are adding, and it's completely new. Every time we encounter the transfer topic of the Moonsama contract, this function is getting triggered, and it will receive this time not an event handler context, but an EVM log handler context. It's a brother to the other one, essentially. It's very similar, but it has further information because it has the EVM information. It has the topics, data and transaction hash, the contract address, and then it has the familiar substrate data. This is useful because, I don't know, for example, you want to double check that you have not used the filtering here, but you want to do different things depending on the topic. So what you can do, you can use the context to say, am I being triggered because of this topic or this other one? And then I can decide which branch of the logic to apply, for example. The actual business logic inside here, it's still pretty simple. It's an example. We instantiate we have an auxiliary function called get or create, which tests the existence of the owner with this address, and if not, it creates it. We update the balance, and then we just save it. And then we have the logic about the token model and token entity on the database. For some reason, I don't know why, I am not using the get or create, but this is what I'm doing essentially. I'm trying to get it from the database. If it's not, I'm going to create it. If not, otherwise I'm going to update it with the new information. I think I left it on purpose just to show that all of this code could have been saved by using a boilerplate auxiliary function that we have. The same thing has been done for the transfer. This time we're not testing the existence, because every time the function is triggered, it's by definition in a new transfer, so we are instantiating a new object. But I wanted to discuss this first line, which is where we are using the events mapping. We are using the decode function that has been automatically created for us by the EVM typegen command line tooling that takes in the context and uses it to extract the transfer information. And we use this information to extract the addresses, the token ID, and all of the data that we then later on save in the in our database. The way it does this, once again, is by using first of all an interface that is has been automatically created for us. It's just the used to move data from various places and stick to sort of like a data contract. But what it does, it uses the ABI library to process it for us. I'm not sure if this was too little or too much, but we can move on if there's no questions. I guess it's a go.
It's a go. There is a question. I'll ask it. I was trying to process it before, but so basically, Hassam is asking, in the code, you create the process ERC transfer. I don't really understand your question, Hassam. Maybe you can clarify it, and we can follow up.
Sure.
Please.
In the meantime, we are using. Go ahead.
Yeah. Please continue.
Okay, cool. In the meantime, we are going to spin up the Docker Compose. Actually, I keep forgetting this. I need to update the presentation. I always forget the -d parameter, which starts it as a daemon, so it doesn't clog up my terminal. But the Docker Compose, like I mentioned earlier, it's just a Postgres database. We obviously need it to store the information, otherwise, where does it go? We build the code. Clean up the existing migrations, because like I said, the project that we start, it's a complete project that already had its own migrations, right? That reflected the schema of that project. And so we need to get rid of them. I think we can skip the database because we just created a new one right here. And then we create our own migration and apply it. Just gonna go through these all steps. Instead of doing the command line version of it, oops, accidentally opened the node modules. The database migrations are here. We can take a look at it, and they are just SQL statement to create and do the necessary changes to the tables. But as we can see, they only have account and historical balances tables. So this migration won't do it for us because our schema is different. We're just gonna delete it. And create a new one. Here, we have the actual command, but I think this is a good time to also introduce the annotation that I have here and why I think they're useful. We have a makefile, because as I mentioned, some of these commands are like quite hard to remember. I use a lot the shortcuts present in the makefile. For example, I can do make build, and this is basically going to run an npm run build for us. There's an error somewhere. I accidentally copied something. Good thing we have a compiler. There we go. Okay, so like I mentioned, it's quite nice. I find it much easier to memorize make build and make migrate rather than this, but it's personal preference. It's just, definitely. I thought it was good to know. So we're going to create a new migration, and it's going to execute this command right here. We will find it. As you can see, the statements have changed because we have like a much different schema. We have owner, transfer, like all of this stuff. This stuff is, as you can see, automatically generated, so it shouldn't be touched manually. Like if you want to, you can create your own empty template migration file, and then you can do whatever alteration you want to, and they are going to be executed, all of them, the automatically created one and the manually created one, when you run make migrate. Just zooming in real quick, it's what it did. It just took a look at the current schema, confronted with the migrations folder, and said, oh, none of this migration have been applied yet, so I'm going to apply them. And this is what it did, right? Create table. You can see all of these statements in here. Next, I think we're ready to launch the project, finally. We have this command right here, which is going to do nothing but launch the node program, the node software, and tell it to run the compiled processor. I'm going to use the shortcut right here. And we have a series of useful loggings in our terminal. This is, by the way, a blocking call. It's going to take possession of the terminal because it's going to keep logging and give us useful information. If you want to have a terminal, we have to open a new window, which is exactly what I'm going to do right here. Let me close this so we have these two side by side. This is just telling me that it has started from block 0. It starts quite slow because, well, it's just the first block, but in a second it's going to pick up speed, I hope. Otherwise, major demo effect fail. And in the meantime, we can launch the GraphQL server. Every Subsquid project has these 3 components: the processor, the database, and the GraphQL server. They all go hand in hand because, well, the processor takes the data from the archive, applies custom business logic, stores it in the database. The GraphQL server takes the information from the database and serves it as an API. We can now visit localhost in our browser at this port, like it's specified in here. And we have the schema. We have the console, GraphQL console, with the specified schema. To answer the question from earlier, this is the schema that is derived from the schema.graphql file. It has a few more things that are just going to, basically, they're useful addition to it. So, for example, we have the transfers entity, right? But we also have the transfer connection, which is useful because it has the total count and it provides pagination. So let's say we want to see how many transfer we have. I don't think it has processed many, so the total count is 0 for now. But this is true for all of them. So we can see how many historical balances we have. We also can do, instead of doing historical balance where ID equal, right? We can do historical balance by ID. It's going to be basically the same thing, but this is a shortcut. Let's take a look at what it's doing, the processor. For some reason, it's very slow to start, and I think the reason is because in order to instantiate the contract, it has to do an RPC call. So once again, this is the only it's the drawback, right, of using RPC calls.
But also, you're starting from block 0, right?
Yes.
And that's incredibly sort of resource intensive. I imagine.
Well,
The further back you're starting, the
yeah,
longer
yeah,
it's
but
going
it
to take to
should, like, it
sync,
shouldn't
right?
be. Well, yeah. First of all, by definition, if we don't specify, that's actually a good
Yeah, so I'm
point that
kind
I
of
take
thinking
for
like my
granted, but
follow-up
I shouldn't.
question is, what would it look like to start at block, 10,000 or whatever, some specified block?
That's
And
exactly
oftentimes, like these
right.
applications, we
Yeah.
also
So
know when there was a change in metadata, or when there was a certain change that maybe, or even maybe we just don't care about events that happen prior a certain timestamp. So yeah, this would be a cool thing to check out.
yeah. So that is we thought about it, right? We thought about it, and you can do processor. Processor dot.
Right.
Now I cannot remember. Yeah, set block range. This is where you specify an object that, if I recall correctly, has a range, and then similar to this, right? You can basically do this thing right here. Now I'm going top of my head, so I'm probably gonna make a mistake, but it's essentially there's an interface to this. Actually, I do better if I check the. I keep forgetting. One of the good points of this. Oh, by the way, it has picked up, right? You can
Cool.
see. Oh, you can see here that it had made a huge jump from 0 to 19%, because if I'm not wrong, this is where it started seeing transfers. It was just basically asking the archive, can you please provide me with blocks? Can you please provide me with blocks? And you can see that it's actually like the ETA, so the expected time to finish has decreased substantially. Sorry, I just saw it and I thought it was interesting to note. What I was trying to say is that by having an SDK such as this one, I use it a lot, but I keep forget to doing so when I'm doing workshop. You can just control click into something and look at the underlying code. So from here, I wasn't sure what to provide, and I just clicked into it, and you see I have an example of how to do it. I can see that I have an interface called range, and if I'm curious about it, I can just drill into it and see that the interface range is actually this guy right here. I can provide a from, like a starting block, and the end block is optional. So for example, if I just want to start from an arbitrary endpoint in the blockchain, I can say it, but then I don't have to stop. I can say from that point onward. So I think this is just the pretty not being happy.
Right, that's useful. We had a question, and we are sort of on the running out of time side of things. That's totally fine.
Sorry.
Just to kind of keep the pulse on things here. So one of the questions is I find it particularly interesting, right? So the question being around, like, how can we use this in a multi-chain kind of model where I should just read the question. So the question is, can you make the same query run against all parachains and only the ones that make sense to return you? So what would it look like to have this run?
That is,
but yeah, across chains.
Yes, that is an exceptional question. Actually, let me go back real quick to here, just saying good job. Congratulations, cool, everyone, for sticking. And it leads to this one, actually. This is an upcoming, it's not a release, it's actually a product that we are releasing. It's like a standalone thing. And this is one of the, the cookie cutter solution that I was alluding to at the beginning. It's called Giant Squid because that's what it is. It has, well, many tentacles, and the various tentacles are the parachains. It's only like, it's still in internal testing. We aim for next week, but you can see already it has one, two, three, six chains right here: Astar, Moonbeam, River, and it reports basic information about the mostly accounts and financial stuff, but not just, because as you can see, it has account, bonds, crowd loans, staking, slashes, and transfers as well. So we have sort of like the same information where available across all of them. And the aim, this should have all 33 of the blockchains that we mentioned before, or any that we want to add in the future. And what it allows you to do is, for example, I think it's better if I show you the documentation, because, oops.
Yeah, so that was spot on, basically.
Yes, because we understand the need. Like, it became became evident very quickly that many projects, especially wallets, this has been developed together with a wallet project. They all need the same information, but they need it across every chain, right? And especially with cross-chain transfers, it's only going to be more and more necessary and useful to have it. This is the documentation on our website for it. You can see the schema here. It's a description of what you can find there, and you have examples of queries of how to do it, how to query this sort of, it's not an oracle in the sense of blockchain oracles, but it's like the place where you end up asking questions about parachains, right? And I think that the most interesting thing is that the account addresses, like I mentioned earlier, the same account has different encoding in various blockchains. That is by design, essentially, and we cannot do that for you. So this is the one thing that you have to do yourself when you want to interact with this tool. You have to be aware that this is the Polkadot encoding for this account. If you want to do the same thing, like do the same query for the Kusama, you have to do the translation yourself. And we have a client example of how to do it. Very easy. You can just start with a node project and install these libraries, and you will have to find an address yourself and do this is where you build the dictionary of chains and encoding, and then that's pretty much it. You generate the query for each chain, right? Perform the query, collect the result, and this is the end result that you will have. So for Kusama, for Kusama, you have account by ID, all of the transfers. I think we did the top 10. Then you have Polkadot account. It's the same account, by the way. This is where we have done the encoding. The top 10 transfers, Astar top 10 transfer. I think this is a validator. That's why it's present on multiple chains. But this is what you can do with it.
Super cool.
One last thing, if there's no other questions, and these are the information that we either already have or we want to add. I think cross-chain transfers are not there yet in the version that I showed you, but we will add them. It's the upcoming sort of release of the SDK. It's a huge release. It has impacts on the archives as well. So a few things change. I think we're running short on time, so I'm not going to be able to show you how to migrate, but I'm writing the documentation at this in these days. And the new release introduces all of this stuff. Those nasty batch all extrinsics that wrap multiple calls. We have found a way to unwrap them so you can process them much more easily. We're adding supports for WASM contracts, which is taking fire essentially lately in the ecosystem. It's very exciting to see. I don't think that subscriptions will be live with this release, but is probably delayed by a couple of weeks. And a few more things like processing in batches. So remember that I said it's going to ask for, the processor is going to ask for a batch of 500 blocks and then process each block one by one. The counter to this, we try to go one step ahead with performance, and optionally, if you want to, just do the processing in batch. So you have to be aware that you're not going to receive one event, but a batch of them. So the processing is going to be look slightly different. You're going to have to loop through them. But the performance improvements is like tenfold or something, 7 to 10-fold. And lastly, I think we tie back to the beginning. We have bounties for Polkadot Hackathon. So if you want to take a look, they're defined here, and some of them are quite interesting. I think like I'm very excited about this. It's very geeky, but it's sort of like a calculation of how much a certain account interacts with the entire ecosystem, and it leverages it should be like, to build it, I advise using the Super API.
Really cool. Really cool. Yeah. Okay. I need to check out the bounty.
Yeah.
I think with what we learned today, I think you did a really great job going over sort of what the architecture is, what the sort of mental model with using these tools looks like. And we walked through an end-to-end example. I'm seeing a lot of people excited in the chat too, especially, like asking some great questions. So yeah, this was amazing.
Yeah, like first of all, thank you again for hosting this, for giving us the opportunity. I hope there's going to be space for us in the coming month to showcase the released FireSquid, and we can talk about the added functionalities. I think it's going to be quite exciting. And like personally, I think that in the space is it's exploding with new stuff, with like it changes every day, so it's hard to keep track. I think I'm very excited about this sort of events or talks where we get to share the knowledge. For me, it's very exciting.
Definitely. Yeah, definitely. And we're actually going to meet each other for the first time when we attend the Polkadot Hacker House in New York next week. Or no,
Yes.
Next week. This is happening already.
Well, a couple of days.
Yeah, actually, some colleagues of mine are helping set up already. So yeah, I'm going there tomorrow. And then for those also who want to participate or learn more about exciting talks, check out Polkadot Decoded. It is happening next week, where we have 2 days of talks, workshops, and really exciting stuff happening all around the world. So make sure that you sign up and either attend remotely, or if there's still some spaces in the cities that you are in, you can attend in person. Yeah, thank you, Victor, for putting that in the chat. Just go to decoded.polkadot.network and you'll find more info there.
I just wanted to say, like, I'm going to do the crazy thing and be in New York for the hackathon and then fly to Berlin, because we're sort of this Subsquid is sort of decentralized, but we're mostly based in Europe. And so we decided to go to Berlin. So for those who are going to attend, our CEO, Dimitri, is going to have a talk there as well. If you're curious to hear about his view for data in blockchain in the future.
Super cool. Well, hey, Massimo, I think that's a great way to end this session. I thank you for really doing a great job on this workshop and teaching us. I've learned a lot. I'm particularly excited about potentially using this in some projects, and I think other people watching still feel the same way. So I will see you in New York.
Absolutely.
And for the rest, I thank the audience for being nice and interactive. And I remind you guys, like, perhaps you have ideas to present also on seminar, and I welcome you. You can check out our repository, which the link is in this video. Massimo, do you have any last things you want to say to the audience?
No, just if you have any questions, if you are curious about anything, if you want to have a sneak peek about the upcoming release, just reach out. I'm here for this. My job is to make it easier for you to be successful with Subsquid. So just don't hesitate.
Awesome. Thank you so much, Massimo. You have a great day.
You too, and thank you once again.